Usually, when we try to detect the presence of extraterrestrial life on worlds other than our own, we generally mention, first and foremost, the Martian subsurface, or the hundreds of exoplanets located outside our solar system, in whose atmospheres we hope to one day detect biosignatures characteristic of living activity. But we forget that today, in this search for extraterrestrial life, one of the most promising places to hope to find it is actually somewhere that, just a few decades ago, no one would have thought to look. Beneath the surface of a frozen body, 10 times farther from the sun than we are, and which literally spits out some of its oceans into space. This icy moon, called Enceladus, is one of the smallest of the giant Saturn. With its roughly 500 kilometers in diameter, the size of this satellite is on the same order of magnitude as the British Isles. Enceladus is practically devoid of atmosphere, so its surface is almost directly exposed to space. And at noon, when the sun is at its zenith, the temperature hardly exceeds -198 degrees. And yet, this world, which resembles more a frozen hell than a little piece of paradise, is certainly one of the most interesting objects to explore in our entire solar system, to hope to find life beyond our planet. This frozen surface, which stretches endlessly, is thought to conceal deep oceans of liquid water beneath it, with possible hydrothermal vents bubbling on the ocean floor. The story truly begins in 2005 when the Cassini space probe set out to explore the giant Saturn. It detected, while passing near the south pole of the small moon, the presence of a gigantic plume of vapor, water, and ice rising several hundred kilometers above the surface before falling back down, but also with some of it drifting off into space. By increasing the probe's flybys, they traced the source of these strange eruptions. They all appear to come from a slightly warmer region and, importantly, pass through many fissures, where temporary geysers often erupt. And it was realized that the power of these eruptions is even enough to feed and maintain the formation of a huge, tenuous ring that Saturn has, the E-ring. It is believed, in fact, that this ring was formed from ice particles ejected by the geysers. And once in space, over thousands of years, these particles would have been channeled by Saturn's gravitational and magnetic fields, to the point of eventually adding a new ring to the gas giant. A ring formed from Plume activity, spewing a bit of a subsurface ocean into space. While the majority of the ice grains emitted will fall back directly onto the small moon as snow. A snow that formed without clouds and whose accumulation can be detected in the infrared spectrum, which allows us to observe the presence, in the southern hemisphere of the small moon, of clusters of snow hills that can reach up to 100 meters in height. The presence of such accumulations of powder tells us that here it has been snowing almost continuously for at least 100 million years. By observing the general morphology of the southern region, we even think that it has been completely renewed more than once. As shown in these images, the presence of recently formed water ice can be seen as bluish reflections in what appear to be huge cracks. To explain these fountains and the continual renewal of this celestial body's surface, all the spotlights are pointing toward the presence beneath the thick ice sheet. Covering the entire satellite with a global underlying ocean, it is now believed that this underground liquid ocean must be separated from the biting cold of space by about 35 kilometers of ice at the equator and around 5 at the South Pole. According to our models, beneath the thick layer of ice, there is a column of liquid water, 20 times thicker than our oceans on Earth on average. And this extraterrestrial ocean must, after about 60 kilometers of depth, finally give way to a rocky base, the solid core located at the center of the small satellite. Overall, the volume of liquid water beneath the thick ice is estimated to be about 1/10 that of the Indian Ocean. That may seem small, but remember Enceladus is modest in size, which means that on the scale of this small satellite, it's actually considerable. So, the question arises, how can we explain the existence of kilometers-thick extraterrestrial oceans in liquid form beneath such a small world, located 1.4 billion kilometers from the Sun? Our star clearly can't provide the solution to this mystery. The amount of energy received per square meter on Enceladus is 99% lower than it is on Earth. And in the absence of an atmosphere, the few rays of the Sun that reach here struggle to give the icy Moon a surface temperature higher than the point at which nitrogen becomes liquid. We also can't attribute this internal energy source to lamps. Radioactive and heavy isotopes like uranium, thorium, or potassium likely sank to the center during formation. On our planet, these elements are responsible for much of the internal heat produced. Enceladus is much too small to have retained its primordial heat. So why isn't this satellite of Saturn, Enceladus, like our own Moon, which, although nearly 7 times larger than Enceladus, has long since completely cooled down? What makes the existence of these internal oceans possible? In fact, such amounts of liquid water beneath the surface can only be explained by the presence of an intense internal heat source deep inside this small icy Moon. And it continues, of a completely different nature. It is believed that this mysterious energy beneath the ice comes from frictional heating, from tidal effects resulting from an unbalanced and ongoing struggle between the small Moon and its gas giant. As Enceladus orbits massive Saturn along its slightly elliptical path, it experiences significant deformations due to the variations in the gravitational force exerted on it. Thus, the depths of Enceladus are periodically deformed as it moves, and these frictions between the elements at its core, these almost continuous rubbings, are transformed into heat. And this effect, already particularly powerful, is also amplified by the fact that Enceladus likely has a porous, water-soaked core, because the small Moon, unlike more massive bodies like Earth, lacks dense, metallic cores. At the center of Enceladus, due to the low gravity, the material hasn't compacted much, and the core likely resembles a gigantic, solid sponge, a vast network of roughly agglomerated rocks through which water can endlessly circulate and warm up. Evidence of these regular deformations of a sponge-like core has actually been observed in the amounts of material ejected into space by the geysers, which vary over time, by following the periodic rhythm of Enceladus's revolutions in its orbit around the planet, near the rings. From this porous core, we've detected tiny silica fragments torn away by moving water. The currents on the rocky beds deep within Enceladus were then propelled into space, eventually becoming part of the famous E-ring. Let's try to follow, by the power of thought alone, the journey taken by these silica particles as they travel from the depths of Enceladus to the depths of space. It is believed that on the ocean floor of the small Moon, cold ocean water seeps into the crust through cracks, flowing through crevices in the rock. Once inside, it heats up, builds pressure, and rises, washing everything in its path. The minerals from the surrounding rocks, such as silica, once they leave the core, these minerals in dissolved form encounter milder temperatures in the ocean and then crystallize. And these newly formed particles will drift for years, even millennia, tossed about by the currents, until one day, some of them, through the play of thermal movements, come together again, at the top of the 60-kilometer thick column of water separating the ocean floor from the thick ice ceiling. Once the surface of the ocean is reached at the south pole of Enceladus, the water loaded with nanoparticles slowly makes its way through the cracks that streak the ice. As the liquid moves through the fractures and gets closer and closer to space, the pressure exerted on it drops significantly, and the carbon dioxide it contains, in dissolved form, starts to form bubbles and fizz slightly. In the wake of these bubbles forming, The water continues to rise until it's about 100 meters from the surface, where it accumulates along with large amounts of gas inside cavities. These huge water bubbles are actually time bombs just waiting to explode. Because the proximity of the vacuum of space and its low pressures can bring liquid water to a boil, even at very low temperatures, and thus cause an instant champagne effect. When the ice suddenly breaks in some areas, these bubbles erupt in a vertical flood of water vapor propelled by expanding gas. This is the birth of a fleeting giant plume, a fountain that, freezing quickly, sees part of its waters fall back to the surface as micrometric snow, rich in silica nanoparticles, while the fastest part goes on to feed the outer ring. Sometimes it can even be accelerated by solar winds, reaching speeds of about 1,000,000 kilometers per hour, and thus rush off toward the farthest reaches of the solar system. And there you'll say, okay, this journey that takes us from the depths of a frozen moon to the far reaches of the solar system. As crazy as it is, it doesn't tell us at all how. Enceladus deserves our attention when it comes to the search for extraterrestrial life. The deep oceans, shrouded in eternal darkness and crushed by kilometers of water, truly resemble a kind of hell. And we're tempted to imagine that any living being, as we know them, would be completely unable to survive there, even for just a few minutes. Except that this kind of reasoning is no longer valid at all, since the incredible discoveries we've made over the past 50 years, just a few kilometers beneath the surface of our own planet. On Earth, up until the late 1970s, almost all scientists agreed that in the deep ocean, in the total absence of light, and without any food source coming from the surface, there was no chance that life could develop and survive independently. And then we began to discover, several thousand meters deep, forms of life evolving in a world of darkness, around underwater chimneys spewing at their tops, burning fluids loaded with minerals, sometimes toxic, with methane and hydrogen sulfide. Discovery of these unique organisms that survive without relying on the sun's energy, and in many ways, they seem a bit extraterrestrial, has come to shake up what we thought we knew about the adaptability of living things. While we had always imagined that, without nutritional input from the surface, nothing could live independently in total darkness, we found at the bottom of our oceans vast colonies of bacteria feeding not on what falls down from the surface, but drawing their energy directly from toxic compounds, minerals, and the heat emitted by hydrothermal vents. And they do this through a completely new process, chemosynthesis. If you're interested, check out the episode we dedicated to the discovery of these aliens from our planet. The link should be around here. If it truly exists as we believe at this moon's core, a continuous heat source that gives rise, in the wake of boiling water coming out of a porous core, to hydrothermal vents. Then, this bubbling environment in the dark depths of sunless realms, which until recently in our imagination was a hell for all living things, becomes delightfully welcoming. As long as you're an extremophile bacterium or any other species of that kind. Tube worms or deep-sea shrimp that thrive near black smokers in the oceans of our planet. Obviously, habitable doesn't mean inhabited. And the fact that some organisms seem to be able to thrive with delight in these deep, dark waters doesn't mean that life can appear there or has appeared there. But this kind of discovery tends to make me personally optimistic, especially considering some terrestrial species prefer other environments that also lack major heat sources, such as these extremophile bacteria that survive in Antarctica under 4,000 meters of ice inside a saltwater lake, Lake Vostok, cut off from the world and sunlight for hundreds of thousands of years. It's easy to imagine Batifol, now near hydrothermal vents 1.4 billion kilometers from the sun, has fallen into darkness. Under 60 kilometers of liquid water pressure and 5 kilometers of solid. Possibly tiny creatures like extraterrestrial shrimp, just a step, a mandible away. In the meantime, and even if the existence of living beings around black smokers on Earth has led us to rethink the possibilities of life existing on other planets, to rethink the possibilities for extraterrestrial life, the existence of these chimneys deep within Enceladus, it's still a hypothesis. One of the most credible, but still a hypothesis. As for the possibility of finding life there, for now it's little more than an appealing speculation, relying on this cocktail recipe, which seems, wherever it occurs on Earth, to have been validated by life. That is, the presence of liquid water, minerals, and at least a minimum amount of heat. And the most exciting thing about all this is perhaps the fact that Enceladus is just one world among many that are thought to have liquid oceans beneath their surface. So, there are almost certainly underground oceans beneath Jupiter's moon. Europa, the only other moon in the solar system, has had episodic plumes of water vapor that can rise up to 200 km above the surface. That's 22 times the height of Everest. On this moon, vapor eruptions release almost 2 tons of liquid per second into space, while the one on Enceladus only releases about 200 kilos. It is believed that Europa hides beneath a layer of ice 10 to 30 kilometers thick, a vast and deep ocean, about 100 kilometers deep. And since this moon of Jupiter is much larger than Saturn's small moon, as shown in this comparison image, Europa may have 2 to 3 times more water beneath its ice shell than all Earth's oceans combined. It's also believed this moon ejects part of its oceans at a certain rate. In space, it is regulated by the variations in tidal forces imposed on it by the shape of its orbit around its gas giant. And, just like with Enceladus, beyond the photogenic presence of the plumes, the existence of this underlying ocean is indirectly revealed to us by the presence of these dark streak patterns that crisscross the entire surface of the satellite. It is believed that most of these ice scars, which can be nearly 20 km wide at their largest, were formed by upwellings of warmer water and ice that cracked and renewed the surface. It is thought that these marks are boundaries, the borders of large ice flows that move apart or come together in a giant puzzle, driven most likely by the underlying ocean currents, powered by the heat from the moon's core, heated from within by the powerful tidal forces exerted by the gas giant Jupiter. Just like the ocean ridges on our planet, at the center of some of these streaks, new frozen ground forms here, and newer ice replaces what was there before. We've identified what seem to be activity traces and subduction zones on Europa's surface. Areas where large icy crusts sink into the moon's melted interior, sliding under other gigantic adjacent frozen blocks in the same way as the movements that recycle the ocean floor on our planet. In a way, it's a kind of plate tectonics made of ice. The wildest part is Enceladus, just like Europa. They are most certainly, because of the existence of their impressive plume, just the tip of the iceberg. We also suspect the existence of liquid water oceans beneath many other frozen worlds, such as Ganymede, Callisto, and even deep within Pluto. And I find it rather strange to think that if Mars, or to a lesser extent Venus, could have been habitable in the past, Enceladus, like Europa, most likely still are today. By the way, you'll probably be very happy to learn whether or not to live there. In about 5 billion years, when our star turns into a red giant and our world gets completely scorched on the surface. The surface of these frozen moons should reach mild enough temperatures to melt completely. And at least for a while, they would be covered with water, this time liquid, as far as the eye can see. Thousands of people have lived without love until now, but no one has ever lived without water.